Smart scopes, the good, the bad, and the ugly. But first, a little bit about me, my background. I'm an advanced amateur astronomer. I am kind of a star hopper by nature. I know the stars, the constellations, and where you point in the sky to find a deep sky object. This was my first scope. It's an Edmund Astroscan. Great little scope, pretty good optics, wide field of view, so it made it kind of easy to find things. I was an educator in many ways. I give a lot of the programs for the astronomy club. I taught astronomy at community college, and I work for Earth Sky right now as a night sky editor. I used to take astrophotos with film. I had a K1000, took pictures with that. And what's amazing is smartphones today can take better pictures than I used to get with film. But back to smart scopes. Do you need to know the sky? I always recommend that you kind of know your way around this. These monthly charts are free. They're in your newsletter and found on what'souttonight.com. Start by picking out the brightest stars, which on this would be the bigger dots. Once you learn the brighter stars, you can start kind of navigating around the sky. The way you use one of these is like if you're looking south, you hold this out in front of you with south matching the horizon, and then the zenith, which is the point over your head. The stars in between the zenith and your southern horizon should kind of match. And then you do the same, you spin any direction, you just hold it at the bottom and hold it up to the sky, and you can start lining up the bright stars and some of the more obvious constellations. These particular star charts, and a lot of them do this as well, will indicate things you can easily see in binoculars. And for binoculars, great astronomy binoculars are 7x50s. 8x56s are pretty good. They gather a little more light and blow up things a little bit more. And 10x50 is the biggest you should go for anything for handheld, because after that you would want a tripod. And these charts, along with many others, will show you things you can see in a telescope. Why do you need a telescope? Of course, it's to gather light and to enlarge things. We all kind of know about how big the moon appears on the sky, and this shows you the size of planets compared to the moon, and they cover a very small area of the sky. So to see planets at all, you need at least a 4-inch or larger telescope. So getting back to smart scopes, this is just off the High Point Scientific website. You can find a smart scope from anywhere from $399 to $5,300. And they actually have add-ons for cell phones from $229 to $300. I don't know anything about them, but they're out there, so you have an option of doing something on your cell phone without even buying a smart scope. But do you need to know anything about astronomy or the sky to use them? And maybe who are the Seestar for or other smart scopes? This is the scope I have experience with, the Seestar S50. It's a 1.97 mirror, f4.9. Focal length is roughly 250 millimeters. Its field of view is 1 degree by 0.7 degrees. That's roughly equivalent to 2 full moons lined up side by side. Its megapixel sensor is 2.1, and it puts out a pixel image of 1936 by 1096. Now, something to think about, the sensor is roughly the equivalent to the first digital cameras that came out, or maybe your first cell phone, smartphone with a camera. So it's not the best resolution. Setting up the Seestar is fairly easy. It comes with a little tiny brochure. You basically turn it on. It connects with your cell phone. It actually has its own Wi-Fi, and it just walks you through the steps. One of the first things you do is kind of level it, kind of let it roam around the sky, sense where it is, get its coordinates, and you're basically off and running. It's very self-explanatory. This is samples of some of the app on your phone. To the left is what you see when you first open it up. You connect to it, And then you can pick if you want to go stargazing, look at the sun, look at the moon, and you can select on stargazing. It will give you suggestions for things in the night sky. Once you do a go-to, the next image here kind of shows you like what it basically does is it stacks the image on your phone, and you can just kind of keep watching it or ignore it. It'll take care of itself. The moon is the same thing. You go to the moon. Basically, you take videos of that, and then the Seestar app will stack it for you. And this last one is kind of where you've just got a frame pulled up and what your options are in that. But basically, after you do the go-to, it finds your objects, and you can just see it stacking an image. It'll start showing you the time, and you can see your images getting better. What do I think it excels at? It's very easy to use, very portable. I don't think you need to know astronomy. It might be helpful, but I don't think it's necessary. It takes great pictures of the sun and the moon. Here's a image that I took of the moon. The best way to take pictures of the moon is to take about a minute and a half video, and then let the Seestar app stack it, and then it spits out a picture that you can save on your phone. And then you can go tweak it in like Lightroom, but it really does a super good job. You can also take images of the moon or live stream it, and you can do 2x and 4x on the moon and the sun as well. But in going back to the low resolution of the chip, they don't turn out too good. And it takes great shots of the sun too. You can see sunspots pretty easy, and even granules on the sun. So that is actually pretty cool. It has a little solar filter that you just stick on the end of your scope. One problem with finding the sun or moon is they don't have fixed coordinates in the sky. And, you know, it's going to know where Polaris is. It's going to know where Vega is. But the moon and the sun keep moving. So obviously, sometimes it has issues finding them. So first, at night, if you're looking for the moon, I just go find a star. And then after it knows where it is, you tell it to find the moon, and it goes right to it. During the day, if it can't find the sun, you can kind of, do a shadow, line it up so you can see the even shadow of the sun on the ground, and you've got the sun. It can run in two modes. One is alt azimuth or equatorial. And the alt azimuth is the original setup. And you can take shots of 10 or 20 seconds. And basically every time you set it up, sometimes you have to level it again if it can't find what you're looking for. It doesn't take that long. You just adjust the tripod leg. Now, if you run it in EQ mode, you need to polar align it to Polaris at first. But after that, you can take 20, 30, or 60-second shots. And the problem with that is if you don't leave it in a permanent spot, you would have to polar align it every time you take it out. What about planets? It's not really designed for planets. Venus goes through phases like our moon, and this is actually when Venus was at its largest or close to at its largest apparent size. And you can see it's pretty tiny. I've taken pictures of Mars and Jupiter, and they both were awful. Mars you could barely see. It was just kind of small and dim, and then Jupiter kind of overwhelmed it. It was too bright, so both were pretty bad. Just kind of FYI, some of my thoughts on this. It's a 9:16 format, and many objects are going to be too big for it. The Orion Nebula gets cut off, and the rosette to the right here, that's, you get about a little over half. So it does have a mosaic option where you can go into your Sky Atlas and pick an object and, just say mosaic and kind of line it out how you want it. One drawback is all the images look alike if you use the go-to. That's because it has a set coordinate and it goes to that, and they all look the same. I work for Earth Sky, and I do deep sky image galleries, and I've gotten so I looked at a picture, it's like, oh, that was a Seestar. So again, they do all look alike, and of course it has low resolution. Looks great on my cell phone, good on the iPad and kind of crappy on my large monitor. This is a mosaic mode of the coat hanger cluster. And I actually had this in the Star Atlas showing the whole entire thing, and you can see the far left star got cut off. But I haven't used the mosaic mode much, so next time I know to make it a little bigger maybe. So here's some of the pictures I've gotten. Got the ring nebula, you can see how tiny it is, but amazingly it looks really good. M13 globular cluster in Hercules, and then M101 the pinwheel galaxy. And I think it does a great job on galaxies. I truly do. And after you've taken an image, you have your own album, and you have to set this option, but you can tell it to save each individual image, and your app has a ability to stack them, or you can export them or copy them over to your computer and process them that way. It'll save them in fit files. And so if you do stack it in the Seestar, you have to scroll through all your images and check any that have a satellite trail in it if you don't want it in your final image. That doesn't take that long. It's not that big a deal. Now the difference between what the Seestar puts out and some other software is dramatic. This is the Bubble Nebula, and the left is what got spit out from the Seestar as soon as it was done. It wasn't stacked. It's just the final image that it did it before I stacked it in Seestar. And then the right is processed in PixInsight. And here's the same with the Owl Nebula and the Elephant's Trunk. And again, the Bubble Nebula. And the Bubble Nebula. And here's M51, the Whirlpool Galaxy. And in PixInsight, you can actually annotate it, and it'll show you all the little tiny galaxies that it gets around an object, which is kind of cool. So do you need to know anything about astronomy or the sky? I would say yes and no. It's not really necessary, but it kind of helps if you have problems. An example is, like I mentioned, I have observed a long time when I've tried to image the beehive, and I've tried it like 3 or 4 times. Every time it goes to, the beehive is M44, it goes to M67, which is also a star cluster in Cancer. And if you didn't know the difference between how they look, you'd be like, I don't know, it's the beehive, it said it was. But that's the only thing I've run into that was maybe incorrect. I don't think it's necessary to know astronomy, but again, it kind of helps. I would say it's really fun to use. I would say it's fun to use. I really am thrilled with the end result, the pictures I get and how easy it is. And it might trigger a new generation of stargazers. So that's pretty cool. Some people are probably just doing this for pictures. And, I'm in a couple of threads online, and some of the people that really are using this are people like me that, just you're enjoying like stargazing from inside your house. So you don't have to pack it up, go to the country. And since it has its own Wi-Fi, you can take it to the country. It's super easy to set up. You just connect it to your phone and you can run it out there. When it's at home, you can have it on your own, personal Wi-Fi. I'm actually pretty impressed with what it does, what it can put out. And I wish it had a better chip. And of course, the more expensive ones do have better chips. So, it's again what you want to invest, what you want to do with them. And so I think it's good for both beginners and long-time astronomers. It's just a fun little toy.